Good morning, everyone, and welcome. The topic of today's online event is Croptech Connect, Agtech Innovations for Canada. My name is Brandy Yanchik, and I am an independent journalist and documentary filmmaker who's based in Edmonton, Alberta, which is in Treaty 6 territory. I'd like to acknowledge the diverse Indigenous peoples whose ancestors' footprints have marked this territory for centuries, such as the Neheya, Cree, Dene, Anishinaabe, Saulteaux, Nakota Ishka, Nakota Sioux, and Niitsitapi, Blackfoot peoples. I also acknowledge this as the Métis homeland and the home of one of the largest communities of Inuit south of the 60th parallel. Before I introduce today's panelists, a couple of quick housekeeping items. If you're having difficulties hearing the webinar at any time today, or you're experiencing an unreliable internet signal, you can always use the call-in number included in your webinar registration email, or by clicking the arrow next to the microphone icon and pressing switch to phone audio. There is a box labeled Q&A, and this is where you can pose your questions to the panelists. If you see a question in the Q&A box that you think is important to ask, you can also click the thumbs up icon on the question to move it to the front of the queue. We will also have a couple of poll questions for you. Today's event will consist of the presentations by our panelists, followed by some questions after each presentation. We will then have a panel discussion around the topic. Please be aware that this event is being recorded. The recording will be uploaded to YouTube, and you will receive the link in an email along with the post-event survey. We will be taking clips from the video and posting these on social media. We do hope that today's event promotes more discussion with a broad diversity of participants. Today, I am pleased to introduce 4 distinguished speakers for our discussion. We have 2 researchers specializing in agricultural technology who will present their findings through PowerPoint slides. Additionally, we are honored to have 2 experts in crop production technology who will offer their insights and serve as panelists in our panel discussion session. We have Slava Adamchuk. He is the professor and chair of the Department of Bioresource Engineering at McGill University and leads the Precision Agriculture and Sensor Systems research team at McGill University. We also have Hanan Asak. He is a program coordinator at the Simpson Center and serves as research lead for the Alberta Digitalization Agricultural Program at the Simpson Center. And we have Corey Wilness. He is the CEO of Croptech Technology, which is an international agriculture technology Agtech company that delivers soil mapping software and hardware. And last, we have Chuck Berstich. He is the president and founder of Haggerty Ag Robotics, which is a leading company in agricultural robotics and automation industry. Welcome, everybody. Now, before we begin, we have a poll question for the audience. And the question is, what is precision agriculture? 1, using technology like GPS and sensors to gather farm-related data. 2, using data analytics to support farming decisions. 3, making data-driven decisions to improve efficiency and profitability. Or 4, all of the above. And you have 30 seconds to answer the poll, after which we will display the results. Okay, the poll is ending now. And the answer is, okay, so let's see here, 0% of you thought that participants thought that precision agriculture is about using technology like GPS and sensors to gather farm-related data. 0% also thought that precision agriculture is about using data analytics to support farming decisions. And again, 0% also thought that it was about making data-driven decisions to improve efficiency and profitability. And 100% of you said all of the above. And the answer to the question is all of the above. 100% of you were correct. And you're going to learn more about it all in today's discussion. So I will now invite Dr. Slava to start the discussion. As you listen to his presentation, can you please think of some questions you'd like to ask him and put them in the Q&A box? Your question, please tell us your name and a bit about yourself, such as your location and your profession. Thank you, Slava.
Thank you for the introduction. Good morning, everybody. It's great to be here in the webinar and get started the discussion on the system approach to precision agriculture adoption. Our team, research team on precision agriculture and sensor systems works on three areas. Primary, it's development and deployment of proximal soil and plant sensing systems, which I'd like to talk about, but we don't have much time for in-depth discussion on this subject. Also, our group works on software for geospatial data processing and management, but the focus of today's presentation is the practical implementation of precision agriculture. And to get started, I'd like to get everybody think about the future of agriculture, like where we're going in terms of production systems, both in plant production and animal production. And who knows, maybe this is the farm of the future. However, I'd like to point out, as shown in this cartoon, that farming is modern farming is very interesting industry where we have traditional concept of having a tractor, plant, soil, atmosphere, interacting with something quite new, such as digital technologies, sensors, computers, drones, etc. In that perspective, when comparing to other industries, agriculture has quite strong potential for automation, and there's quite a lot of projects geared toward that direction. In this report, which is already almost 10 years old, we can see how the strategy of technology development, when we have automation, robotics, imagery, and sensors, the entire phenomenon of big data and digitalization, some of bioengineering concepts are getting converged. And according to this specific report, in maybe 10, 15, 20 years, we are going to see this convergence. Like this report called it robotics, but we'll see what the actual name would be. To start discussion pertaining to precision agriculture, I'd like with a formal definition of precision agriculture that's put together by International Society of Precision Agriculture, and this is the latest edition in English. It's available also on quite a few different languages. Precision agriculture is a management strategy that gathers, processes, and analyzes temporal, spatial, individual plant and animal data and combines it with other information to support management decisions according to estimated variability for improved resource use efficiency, productivity, quality, profitability, and sustainability of agricultural production. In a general sense, this is photograph from International Precision Agriculture Conference that we had that we housed in Montreal in 2018, and Chris Patterson is one of leaders of precision agriculture innovations here in Canada, started his presentation by simple statement. It's not rocket science, it's much more actually. And yes, our industry presents quite a few challenges that dynamic in nature and have to be accounted for. Right from the beginning, I'd like to point out that precision agriculture it's not a magic technology that quite a few users believe to be. We still have to resolve generic production problems. That's why system approach is an important component for precision agriculture adoption. We still need to like precision agriculture cannot transform stones into fertile soil, so we have to have a responsible relationship with the resources that we have. It cannot make it rain more or less. We need to account for weather. It cannot make a bad machine do a good job. So maintenance of equipment is quite important. The value of currency also cannot be affected by precision agriculture. However, we have a set of tools and technologies that can help diagnose production problems and direct toward potential solutions. This slide illustrates some of numbers that we got from Purdue University Precision Agriculture Services Dealership Survey. To my knowledge, that's the most extensive survey that's been consistent for at least a couple of decades. Run by Purdue University, and before that it was Top Farmers Workshop Survey, which also looked at adoption of new technologies. And based on these statistics, we can see that some of precision agriculture tools, such as GNSS-based guidance of agricultural equipment, already been adopted by majority of users across North America, and some of technologies, for example, like individual section control and so on, also rapidly been adopted. The reason GNSS-based auto guidance has such popularity, because it's feasible, and those photographs and graphs and the chart coming from our original work on determination of the accuracy of auto guidance equipment. We had a few field trials and develop camera-based technology to actually measure accuracy of tractor guidance with 1 millimeter precision. So, and using this technology, we could see that in some cases, like for example, test A, that's a fine-tuned tractor with like engineer from the manufacturer of the system was on site to make sure that the vehicle operates to the best its capability. We see that at the regular planting speed, we can be under 2 centimeter accurate. And this specification is already valid for over a decade. So that's why we have adoption, because we can do this. So we basically can talk about farming by individual plants. Test B relates actually to tractors that we just took from the farm without any adjustment. So it's more realistic. So it's basically 5 centimeters, but it's still quite impressive considering the dimensions of the vehicles that we have these days. Other type of technologies that I just want to mention here is machinery tracking, especially for service providers, for customer applicators, quite important. For example, in this case, we had 450 pieces of equipment with small GPS attached to the machinery, and dispatch could see and monitor operation of every equipment. And these days, quite a lot of dealers and so on have also ability to access vehicle information and provide better control on the services. Another example that I want to provide, it's cultivator guidance for organic row crop production. It's using of machine vision to guide implement in real time, and that's relatively low-cost technology that also can significantly improve efficiency of machine operation. I already mentioned individual unit control. So things like skips and overlaps are getting more historical. So we already have a significant reduction of chemical use, seed material use. We reduce competition from crop of the same species for water, for nutrients, by implementing this technology. So basically, it's obvious that skipping and overlapping, placing agriculture output, agriculture inputs outside the cropping area should be avoided, and this technology allows us to do that. On the other side, foreign nutrient stewardship is something that's quite popular in Canada. So we are looking at right fertilizer source, right rate, right time, right place. And that's, of course, on the right rotation, right tillage. And that's a rate is one of variables that precision agriculture been geared to identify. However, if we're looking at the same statistics from Purdue University, variable rate technology is not as heavily adopted as auto guidance system. And there are several reasons for that. and partially because not every site is suitable for variable rate application, but also in order for variable rate technology to be profitable, we need to have certain conditions met. So in terms of technology, this can be done. In this example, we have a piece of machinery that can deliver 5 different products. So basically, we are talking about seed, liquid nitrogen, granular phosphorus, potassium, sulfur, 5 products, all in different individual rate and all at the same time. And the data, the task for this controller to do the job is translated remotely through slingshot technology. So it was done over 10 years ago, and now pretty much every machinery manufacturer has certain capabilities to do something similar. So we have a good handle in terms of what can we do with the material on individual piece of land, or even to some extent individual row. Also, from some of the trials that we run, the feedback that we get from this equipment is quite important to see what actually happening, just quality control. So when we looking at the return of investment of precision agriculture technologies today, the majority of this coming from system change. So basically, when we start talking about precision agriculture, we are talking about no-till and conservation practices. And so on. Also, quality control and logistics, another important component. And of course, variable rate technology, once conditions are suitable, is another big portion. The impact on profit, it's geared by basically conditions, by time, weather, market, management constraints, and application rate is basically one of optimization factors that we can find. So from engineering viewpoint, in terms of control problem, we are dealing with 2-level control. At one level, we got to select what's the best cultivar, soil, weather, economics, risk management. So basically, what's the best management practice? And then we have this variable rate technology. And I mentioned about conditions when variable rate technology makes sense. It is suitable when we have distinct difference in site-specific needs, at least 2 different locations. We have means to recognize the variability, and we have responsive application tools. I already mentioned that we do have decent responsive application tools. Quite a lot of places we have distinct difference in site-specific needs, but means to recognize this variability, that's basically main goal of our research team. And we're discussing of the sensor systems for detecting plant and soil properties could be another topic of discussion. In terms of upper level control, we're talking about different decision support tools, and our group is also working on that when we're looking at the historical data, like when we have connection between location, time, and management. We have some of the online resources, and we combine it in numeric simulation form to see what would happen, like how much profit one would get if pursuing one or another management practice, for example, like different type of application or different application rate. As a trial version, we have this numeric site where we looking at optimization of nitrogen use for corn. There is a form, and then you can get a response like this. So what the maximum expected net return on cost of fertilizer is achieved with what application rate. Then we also can see what would happen if we have different rate, and what's the probability of achieving different level of profit if you have different application rate. In terms of lower level control, it's again already classical site-specific crop management circle, and sensing is a main keyword here. So we have in-season imagery, we have real-time sensors that can be installed on machinery to do real-time control, or we have off-season imagery and sensor-based mapping. So basically now, in addition to the cropping season, we also have mapping season, which ironically quite short considering Canadian climate. So sensors can be remote sensors, satellite, aerial, drone, or it can be proximal sensing using on-the-go sensors, on-the-spot sensors, or profiles that address different depths. So the key element of this dealing with sensor technology and such intensive data, it's data integration. So we have sensors data, topography, yield data, remote sense imagery. They combine together with lab data and farmer experience data, and then through decision support mechanisms, we go either with best management practice, so we optimize the overall work, or we switch to variable rate technology. A sensor fusion is important component. Like in this example with mobile sensor platform from various technologies, we have apparent electrical conductivity, soil pH, soil optical reflectance, subsurface soil optical reflectance, connected together with topography and lab data to get a decent map. So for example, if you want to do variable rate liming, this is the most advanced technology to look at the map, because you have intensive soil pH mapping for water pH, then also optical reflectance, a proxy for organic matter, soil EC is a proxy for texture, together buffering characteristics of soil, and together we are looking at lime requirement. Also, it's important to note that turnkey technologies have been adopted more rapidly than technologies that require entire system. So as one of the concepts that our group been working on is the smart tractor concept. So we wanted to see if it's really possible to make variable rate technology as easy as auto guidance. So can we have operator involved in defining variable rate technology? And as a controller, we could use computers that's already located inside tractor as a pulling unit. So one of examples of this, and the interface is on the left bottom, that's a proportional controller, where we were putting different rate of liquid cattle manure in response to the elevation. So we put more manure in environmentally less risky areas, and that's done automatically. So we have also like with traditional guidance A, B, and then the travel speed of the tractor is matched to the topography of the field. Another example for this would be forage harvesting, where we have ultrasonic sensor also guiding travel speed of a vehicle in front. So we make sure that the cutter bar is always working at a nominal capacity without overloading or underloading. Another example that our group tried a few years ago is variable depth planting. So we have moisture sensor in front of the planter, and based on the moisture, we put seed lower and or higher. And from one of the trials, we could see that just using this technology, we can assure a more uniform emergence, and we could gain half ton or up to 1 ton of additional crop, especially in areas acceptable to ponding and slow warming in the spring months. So to conclude this brief introduction to precision agriculture technologies, I'd like to make this formal statement. There is no such situation where precision agriculture doesn't work. However, there are many instances where promoted solutions are not appropriate for solving a given set of problems, or not executed correctly. So adoption of site-specific management is actually site-specific. That's something that you need to keep in mind. And there is an entire army of service providers and researchers working on this. So it's quite a bright future in terms of adoption of new technologies on a wide scale. Thank you very much for your attention. We'll be happy to answer any questions.
That was fascinating. So thank you so much, Slava. I love that slide with the person on the beach watching their farm taken over by AI and all these different machines. So fascinating. And you gave us lots to think about. Now, Corey, I'm going to ask you to join this discussion. Can you tell us a little bit about your company, Croptomistics Technology, and the services it offers to producers? How do you see the future of agriculture with all the new technologies being delivered? And then I'm going to ask you to ask Slava some questions. So Corey, if you could just tell us a little bit about your company first, that would be great.
Yeah, me personally, I've been a precision agronomist since 1998. I worked with yield mapping and a farm under had full variable rate back in the day. Started as my own independent consulting business in 2003, and as of today, I'm the CEO and co-founder of Croptomistic, and we are well known for our Swap Maps brand. It's soil, water, and topography maps. It's a integration of soil layers to turn them into a single zone map for variable rate application of soil applied products. And we also have a hopeful, what we call SWAT ecosystem of hardware, software, support, training, and services for farmers and other businesses to adopt the technology. And I'll just finish with a few statistics where we have 80 staff, we're in 4 countries, we have 80 B2B business partners, work with thousands and thousands of farms. And since 2008, when we started Swap Maps, we've applied 20 million acres of prescriptions. So that's a little bit about us.
Oh, fascinating. Corey, do you have a question you'd like to ask Slava after hearing his presentation, please?
Yeah, I am impressed with the work that you're doing at McGill, and I would say it's very common for companies like ours that are commercializing technology to either A, look at it and say, we'd like to use it, so how do we do business? Or B, we bring projects to, people like you to, to help us build out something that we feel would be of use. And the biggest challenge we found in Canada is working with research agreements with the different universities, like in the sharing of IP and how it gets commercialized. And so I noticed you've been developing quite a lot, and I was just wondering if you could comment on your experience with commercializing technologies, getting them out into the market where people can use them.
Well, thank you for a great question. And yes, our group is working with industry quite closely. So we at different levels. So we work with machinery manufacturers, we work with service providers, and we will also work with some of producers, like on specialty crop and so on. So depending on the a scale of the project, we can either produce one of a kind for a specific application, or we can develop technology and get it licensed. For example, like a mobile sensor platform, it was licensed to various technologies, and now it's in use pretty much globally. And quite an array of different projects go through the same strategy. And McGill University has quite a good office of sponsor research with technology transfer capability. So in terms of licensing and IP and so on, it's all depend on the research agreement. But we do have in place some of the template, and we have examples of success stories that we can follow on. So it's the system is working, and we can hopefully collaborate together.
Thank you so much. I'd like to invite Chuck to the conversation. Chuck, can you tell us about your company, Haggerty Ag Robotics? And then also I'll be asking you if you'd like to ask Slava a question.
Thanks, Brandy, and thanks, Slava, for the presentation. We started 20 years ago in the traditional precision agriculture space when it used to be defined as adding a GPS and an auto steer system onto a tractor. That's kind of where this space started. And that has evolved over time, as you alluded to in your presentation, that now precision agriculture is kind of encompasses everything. And in our company, when we moved, we do a little bit of everything when it comes in terms of soil testing, providing solutions to farmers. And 3 years ago, we started providing robotic solutions to crop agriculture. So we started looking at, what it's really the next step of precision ag. It's basically removing drivers where it's appropriate, that kind of thing. And so right now we have 29 different robots that we have deployed between Ontario and the US, from different manufacturers, these kinds of things. And we're trying to figure out, how these robotic systems fit into the agriculture space, and we're trying to make that easier for farmers to adopt them. That's basically what we're up to. A question that I've got for you is, when we're looking at the different tools that are available to farmers, one of the things that always seems to come first is a push to remove the human from the decision-making process. There seems to be a real push to replace human knowledge with how to produce the crop. And I'm wondering whether that's really that important. Do we actually need to remove the agronomist and the farmer, or is it more important to enhance that human knowledge and reduce the pain involved in agriculture? Like, is it more important to make it easier to farm, to reduce the work and the labor, or is it the sensors to replace decision making? And what your thoughts are on that?
Well, thank you for a great and very complex question. So it's more on the philosophical side in terms of labor. So the reason we are talking about robotics, because agriculture as labor engagement industry is quite boring. In some places, it's a job security issue also, but in industrialized countries, it's been more archaic type of operation. So, but it's quite important operation. And what we can see is that with engagement of new tools, we can look at improvement of some of the stats in terms of profitability, in terms of capacity, in terms of efficiency of production, which actually parameters link into sustainability, because the ultimate goal is to have sustainable food supply system. Period. That's a food security issue. So how do we achieve that? Like, is there a certain operation, for example, when dangerous chemicals are involved, or when operation is very tedious, and like, for example, mechanical weed removal and so on, where robots actually can help? Yes, that's definitely an area to look at. But in terms of decision-making process, it's not the issue of removing an expert from the field and substitute with artificial intelligence based decision support tool, is to equip a person, an expert in the field, with tools capable of analyzing multiple data sources to make sure that final decision is best possible. Kind of like in medicine, we have robotic surgery, but you want still to see a physician, and despite all the excellent diagnostic tools. So here is the same issue. We have better data, better quality data. We have better understanding of what's happening in the ground. We can better ability to predict what will happen, considering unstable weather pattern. But it's still got to be a human decision in terms of which way to go. And also we need to keep in mind that the level of uncertainty in some of the models is so big that we cannot guarantee the accuracy of prediction models. So it's all the information is taken with a degree of uncertainty. And you really need to have person on the ground who take responsibility, like in aviation, you have many different gadgets and so on, but every time you still have pilot in command who is responsible whether plane will land in the where it's supposed to, at the time that it's supposed to, and everybody on board is safe. So in agriculture, farmer is that pilot in command.
Thank you.
All right, so I want to thank everybody for their discussion, but before we hear from our next speaker, we're going to do another quick poll question. You have 30 seconds to answer the poll. How do you think the application of artificial intelligence benefit producers? 1, by improving crop yield predictions and management. 2, by optimizing resource usage, water and fertilizers, etc. 3, both by improving crop yield predictions and optimizing resource usage. Or 4, not sure. You have 30 seconds to answer this question. Okay, the poll is ending. And in response to the question, how do we think the application of artificial intelligence could benefit producers? 4% of participants said by improving crop yield predictions and management. 4% of participants said that artificial intelligence could benefit producers by optimizing resource usage, water, fertilizers, etc. 83% of participants said artificial intelligence can improve crop yield predictions and optimize resource usage, and 8% said they're not sure. And the answer to the Zoom poll is artificial intelligence is used to improve crop yield predictions and management and optimize resource uses by analyzing large amounts of data from various sources. I'll invite Hanan now to share his presentation. We are getting some questions from you in the audience, so please keep those coming. Remember to type your questions in the Q&A box. When you ask your question, we'd really like to know your name and a bit about yourself, such as your location and your profession. So please include this information. Thank you, Hanan.
Thank you, Brandy. It's been a good discussion so far. So the Simpson Center is working on Alberta Digitalization Agriculture Program, which has been funded by the government of Alberta. And as part of this initiative and among various other studies, we are conducting a scoping review of research on digital agriculture technologies in Canada, and I'll be sharing some of the findings from this study. So let's start by acknowledging some of the key challenges in our food system. So production needs to meet growing demand. Sustainability is critical to protect our environment, and efficiency is essential for economic viability. And one promising solution gaining traction is sustainable intensification. So this approach aims to boost productivity while minimizing environmental impact and ensuring we can meet future food demands responsibly. So how do agriculture technologies fit into all of this? As Dr. Slava showed, technologies like AI, robotics, sensors and sensor networks, and data analytics empower producers to optimize resources, make informed decisions, and enhance productivity sustainably. So it is important to define digital technologies before going into the objectives of this study. So digital technologies refer to the tools and techniques that collect, collate, analyze, and disseminate data, often in large volumes that are relevant to food production. So these technologies include, but are not limited to, drones, satellites, analytical platforms. So in this review, we attempt to address 3 research questions. So first is, what are the prevalent digital technologies and methods currently being explored in Canadian crop production research? And what are the practical applications of various digital technologies and methods in addressing challenges related to crop and soil health, pest and irrigation management, etc.? And what are the ethical considerations associated with the adoption of digital technologies and methods in crop production? And what are the perspectives of Canadian farmers and industry stakeholders on the opportunities and challenges? Yeah, so for this scoping review, we used a broad PCC, population context framework, to identify the main concepts of the review question, to inform the search strategy, and to help with the identification of the inclusion and exclusion criteria. So the population element of our framework wasn't applicable because we didn't focus on any specific group of participants. Instead, we developed definitions for the two key concepts: digital agriculture, as I mentioned before, and social and behavioral science, which were crucial for guiding the keywords that we included in our search strategy. And we explored various databases for published research and gray literature using inclusion and exclusion criteria. So we included the abstracts of primary research studies published in peer-reviewed journals, theses, and government documents after 2013. We also included the abstract that referred to digital technologies usable on field level in crop production systems in Canada. And they included principal field crops, which is the classification used by Statistics Canada. And then the abstracts on analysis of policies and other socioeconomic aspects of digital technologies. We excluded the articles published prior to 2013, the studies that were not conducted in Canada, and pre and post-harvest technologies were also excluded. The next, please. So there were a total of 1,283 abstracts that our search strategy provided us with. And then out of these, we reviewed 173 full text papers and decided to include 82 of them, which met our selection criteria. Next, please. Next. So we used a sectoral innovation system approach to conduct our and structure our review. So this framework includes various actors like entrepreneurs, consumers, and scientists. And these actors work together to develop, produce, and market both new and existing products for specific uses. So they share a common knowledge base to address the challenges. And these actors, they have unique skills, goals, and organizational structures, and they interact through communication, cooperation, competition, leadership, and all within the established institutional frameworks. And that's how they come up with new and innovative ideas that are then converted into marketable products. So the main stages in the innovation process were identified in literature as basic research, basic and applied research, prototype stage, testing and validation, then serial production, market launch, and the adoption and diffusion stages. So these can be categorized into three broad stages: validation, production, and adoption. And among the papers selected for review, there we found out we categorized the final selected studies into technical and qualitative studies. The technical studies reflected on the validation stage of the innovation process, and the qualitative ones debate the production and adoption stages by including stakeholders' perspectives and analyze them under different frameworks. And we integrated both technical and qualitative data within this framework to gain understanding of the digital agtech innovations and their dynamics. Next, please. So as Dr. Slava explained earlier, in modern agriculture, data collection leverages advanced technologies. GNSS, this global navigation satellite system, they provide location data. Satellites offer high-resolution imagery for monitoring large areas. Drones enable aerial surveillance, and so on. These technologies facilitate comprehensive data collection across fields, which is then analyzed and evaluated to map soil, crops, and yield, which helps in planning resources and optimizing input usage. If we go one step further into the complexity, machine learning algorithms can also be used to process this data to identify patterns and correlation, which enable predictive prediction of crop yields and disease outbreaks, etc. And these insights inform precise decision-making in agriculture. Next, please. So we categorized the technical studies in terms of their intended uses. So apart from one study that compares multiple algorithms to predict soil moisture using cell phone images, all the other studies on soil moisture estimation utilized remotely sensed data. So this included satellite imagery, different bands, radiometer retrievals, radar observations, and soil moisture is estimated using various data analysis methods, including the advanced machine learning models. So there was one study that also used this decision support system for agrotechnology, cropping system model, which is used to simulate crop growth, development, and yield, as well as soil, water, and nutrient dynamics. So all these studies used algorithms to train models based on field observations and to make close to accurate predictions of different parameters. Similarly, a good number of studies predicted or mapped soil properties. Most of these studies, which are done by Dr. Slava's team, used proximally sensed data, such as invasive soil electrical conductivity and non-invasive electromagnetic induction, topographic data sensors, gamma ray, and mid-infrared reflectance spectrometry. So a couple of studies also use satellite and UAV-mounted sensors to estimate organic nitrogen and other chemical properties like pH and chlorophyll, as mentioned in the earlier presentation. So, and one study demonstrated the potential of fusing proximally sensed data and remotely sensed data for even better prediction of the soil properties. Next. Next, please. Okay. Can you go back, please? Yes. So there were 13 studies on crop yield prediction that use proximally sensed or remotely sensed data again. And these studies on crop and parameter estimation and yield prediction mainly involved the variables or parameters like leaf area index, canopy nitrogen levels, crop biomass, and chlorophyll levels. Next. While on the other hand, the qualitative studies, they look at the later stages of the innovation, which are the mass production and diffusion. And they take either positive or normative approaches, which are done under different frameworks. The science and technology studies framework suggests that scientific and technological knowledge is shaped by cultures, practices, and institutions, and they influence technology adoption. And these type of studies focus on digital Agtech adoption, privacy, and data ownership and ethics. There is another framework that is a political economy framework under which the analysis is done to study the shift from local farm management to corporate dominated production and to examine power dynamics. Similarly, normative studies, they suggest how the state should come in to govern the data-related challenges and ensure inclusivity. Next, please. So these were some of the applications of the digital technologies that we reviewed: soil management, crop management, farm, pest and disease, and irrigation management. And the general conclusions were that they compared accuracy of different machine learning algorithms in predicting yields of different crops under various conditions, or evaluated the prediction accuracy using different types of remotely sensed data sets, evaluated performance in case of individuals versus fused data, or one method or the other, and validated predictions using simulation models. Next, please. So the research on, so we found out that the research on digital technologies is more on the assessment of potential side, and the method and the algorithms, they have been validated under certain conditions, which require further research and validation. And the results of most of these studies, they feed into the decision support systems and analytical tools used in estimation and prediction of soil and crop characteristics. And the direct users are equipment manufacturers and service providers. And there are some prototypes of new sensors and soil analyzers, which are not yet commercialized. and other experimental stage technologies were also there, which are not available commercially at this point. Next, please. And then there were qualitative studies. They mainly talk about the adoption rates of adoption and determining factors. The overall finding is that adoption of digital technology in Canada is on the lower side. However, there is one recent study that argues that 33% of the crop producers in Canada are high-tech farmers who use multiple technologies, including field mapping, variable rate, and management softwares. But the more important question is whether ownership of technology results in data collection, analysis, and making management decisions or not. And the issues that are highlighted in these studies are mainly related to the unclear return on investment, the concerns related to data ownership and control, and the fears about data security. Next, please. So these are some of the recommendations that we can draw. So while knowledge creation and validation of technologies is adequately funded, and there is significant venture capital funding available for early stage startups, late stage funding is squeezed because of perceived low demand in the market. And this gap needs to be bridged. There's a holistic sectoral innovation approach that is suggested in literatures and by the researchers, and which advocates for responsible research and innovation by adding stakeholders into this whole process. And the need for data governance, which is being filled currently by initiatives such as Agtech, Transparent, and Farmable. And the government may need to step in to do the data regulation and tackle the privacy issues and provide robust data security frameworks. So that's all.
Thank you so much, Hanan, for that great presentation. You gave us so much to think about, and especially those recommendations. I have a question now for Chuck, and the question is, do you have a question for Hanan? Would you like to get involved and ask Hanan a question?
Well, I think one of the comments that Hanan made, right at the end of the presentation is the concern on ROI and what is the return for farmers, because that really drives a lot of adoption. And we're interested in the sensor and technology space because the question is always asked about the robotic technology is, what else can it do for the farmer? And the obvious thing is that if you have a robot that's going data over and over and over again, in a more stable environment. So the question that I've got is, in your studies or in the research, how much discussion was collected or in the studies on who pays for this data collection? Is the expectation that the farmer is going to pay or that someone else is going to pay? And I'm going to use the example of yield production or yield estimation, let's say in corn or wheat or soybeans. As a farmer, knowing what my corn yield is going to be doesn't do anything for me, right? So as a farmer, I'm not going to pay for a service to estimate my corn yield because I can't do anything about it. So, but it might be of great interest for crop insurance and for Agricor or for the government. So how is that question being addressed as to who pays?
Yeah, this is a great question, and some of the researchers they suggest that it should be shared by the farmers and technology service providers, because of course data collection is expensive and it involves a lot of investment into technologies that collect data. But with unclear ROI, farmers alone cannot undertake all this alone. And so there is one of the initiatives or one of the for-profit ventures called Farmable. They have this model where they they not only collect their provided services, they not only collect and analyze data, but they also pay the price to the farmers for their data. So these kind of models where farmers are compensated for the data that they collect, only those kind of models would make sense to farmers who are on the margins and don't see enough returns on their investment. But that is not very common, but a lot of companies are taking this space.
I'd
Thank
love
you.
for Corey to get involved in this conversation. Corey, do you have a question for Hanan after his presentation or a comment?
You bet. Thanks, Hanan. About the last slide there on the competition side, seemed like you were suggesting like data governance or regulation to ensure competition. As a person working in the industry, I feel like there's plenty of competition. There's billions of dollars of venture capital pouring into the ag tech space. Like with Chuck's business, there's probably 20 companies working on robotics, lots of people that I'm competing with. All the big ag companies are investing too, and lots of them are using it practically as loss leaders. Like if you could look at their books, they don't make money on their tech. They're just using it to, draw people into their digital platforms and stuff. So I guess my question is, why do you think that, you would need data governance or regulation to ensure competition?
So it's more about ensuring transparency in contracts between technology manufacturers and farmers. And also regulation for data security. For example, these initiatives like Ag Data Transparent, as I mentioned in the presentation, and also such platforms like Adapt, where big manufacturers like John Deere, they adopted those frameworks to allow more interoperability. So they all strive to make this whole exchange of data between the service providers and the producer more transparent. So this is the space that is being taken up by the private sector itself, and which is a clear indication that there is no such regulation by the government to make this whole space comfortable for the actors who are in play, and is being taken up. So that is what I refer to as. But when it comes to competition, of course, there's a lot of competition, but there are also vertical integrators like big companies, big manufacturers, John Deere, etc. So this confines the market power and concentrates it. At least that's what the literature suggests. And this also increases the risks of security breaches when all the data and a lot of data is held by or is concentrated. It increases the vulnerability of the whole system and makes it a cybersecurity risk. So this is all where some kind of regulation could make these things clearer.
Well, thank you so much, everyone, for the great presentations and this discussion. We're now going to move into the panel discussion, and we want to hear from you, the audience. Please continue to put your questions in the chat. Tell us your name and a bit about yourself, such as your location and your profession. And we have a few questions to prepare to start us off. Then we'll take more questions from the audience. So please put those in the chat and upvote the ones that you'd like to see our panelists address. So the first question is open to anyone. With all the new ag tech coming out, it seems like agronomists will also need some training to understand the technology and do the database analysis better. Will tech manufacturers adopt this role in the emerging markets? Who wants to take that one on first?
I can tackle it first, I guess.
Go for it, Corey.
Specifically to us, like if you become a servant, I guess that's part of our business model, is someone that's been an agronomist for years. Obviously, as you build your business and you work with farmers, you need to make it scalable, right? And to get the technology out, I mean, that's what our system's all about, basically. So if someone can be new and sign up as a new precision agronomist delivering SWOT maps. It's a complete front to back process that's already developed. There's software process for everything. There's support staff, there's training modules. So I guess I would feel the answer to the question is definitely yes. If you want your products to succeed in the market, you better be supporting them and training them and have the people and resources in place to make it work.
Slava, would you like to comment on this?
Yes, from a viewpoint of educator, we do have some significant changes to our academic programs. This is not just unique to McGill University. Quite a few educational institutions across Canada addressing that. So the new graduates, they have skills that previous agronomists and technology experts would not have. And also there is several outreach opportunities in terms of workshops and seminars and so on that are available, especially for CCA credits and other elements for people both in Canada and United States to gain additional expertise in this field.
So
I
I just want to ask, like, while you're answering this question, Slava, can you please get your return on investment slide up again? Because somebody from the audience wants to see it and you to just describe it again. So go ahead. What were you going to respond to that, Corey?
Well, no, so I was actually going to add on to Corey's comment and Slava's that what's really interesting in this space is that if you are an experienced agronomist that starts to use the tools like what Corey provides, you will put yourself multiple miles ahead of an agronomist who's not using them. Like, these tools and these technologies allow you to scale up and multiply your business a lot faster if you have the background knowledge. So the agronomy side is really important to have that, to have the skills as well. What I find that these tools don't do is they don't give you any shortcuts. You still have to have the base agronomy behind you to be able to use the tools effectively. And that, we can't forget about that.
Thank you very much. Yeah, so here's the return on investment slide. Can you just talk a little bit about this slide again? We have a question from the audience. They just want to know more about it.
Okay. The return on investment is combining effect of several actions taken by the practitioners, by adopters, and the sequence of these actions depend on the status quo. So what's the starting point? Because you can have a quite archaic production systems where no matter what you do, you are going to have a positive impact. Like, even if without buying new gadgets, but just restructuring operation, that's also can be done. So through personal experience, not only in Canada, around the world, we see that when we implement precision agriculture, because now you have a system that forces to look at the bottom line, forces to be more organized in terms of operation, better connection, better agronomy, better technology support. A lot of benefit is actually coming from this system changes. We are talking about more than $50 per hectare on sustainably, like with accounting for depreciation rate and investment and everything else. So quality and logistics, that's another improvement, especially for cash crop producers, like when you deal with a larger amount of land and so on. So basically you do your diligence in terms of production operation, but now you can export it or apply it for larger area of land, and some of service providers like Corey mentioned, and so already able to distribute this over millions of hectares of land, like with better control and so on. With variable rate technologies, the reason I put moderate number, because we are trying to compare best management practice versus variable rate technology. And what we found that because we don't always have best quality data as input source, or uncertainty is so high, then variable rate technology can actually put people in red. It could be a place where people lose money because you're overreacting to the conditions that you see. Like we have quite a lot of anecdotal examples, like variable rate phosphorus management based on hectare grid sampling. So that's a recipe. If you don't take into account past management history in terms of feedlot location or boundaries on the field, or if you don't handle source of variability, then doing variable rate technology is worse than doing uniform rate technology. So one need to be quite careful there. So when mentioned this estimate, I'm talking about variable rate liming, variable rate nitrogen, to some extent variable rate management of plant protection products. The saving is relatively moderate. It could be more than $100 in specific feed location, but then when you even it through the rest of the farm, it's pretty much going to be within this vicinity. And we are getting this data through modeling. Basically, we have methods where we can see what's the net return over cost of management practice if you pursue uniform application versus if you pursue variable rate application using specific technology. So basically, it's apple-to-apple comparison. However,
Fantastic. Oh, sorry. Go ahead, Slava.
Warren, that there are quite a lot of reports where comparison is not fair because they try to take a very very traditionalistic system and employ everything together. So you don't know what's going to provide the biggest return of investment. Thank you.
Thank you, Slava, for digging deeper into that slide. It's always nice when people reach out and say, we want to know more. So thank you so much. Chuck, you mentioned you have a follow-up question about something we were chatting about before. Who is mostly interested in data transparency, the farmers, manufacturers, or the suppliers? Chuck, do you want to touch on that first?
Well, I think some of this is playing devil's advocate a little bit, because we hear a lot about data transparency and you know, who has access to it and who is sharing it, and then these kinds of things. And I'm going to argue that, you know, I farm as well, and the data that, you know, on Chuck Barisich's farm in Southern Ontario honestly isn't worth anything. Like really, it's just like if somebody's willing to pay me for it, that's wonderful. But it's that my little bit of data isn't worth very much. But if you have a company, and I'm going to pick on, you know, Climate or John Deere or Case or whoever, that can aggregate thousands of acres of data, tens of thousands of acres of data, maybe it has some value. And so sometimes I think the data transparency side of things and security really is something that's being pushed by an equipment manufacturer or a technology company, probably more so than the farmer is. And I'm just curious what the other panelists think of that.
Well, I always have an opinion on everything, so I'll jump in on it. Like I would agree, Chuck, like we work with thousands of farmers and nobody really talks about this, right? Like they're just working with us to give us take all this data and do something with us, provide us with value, make it easy, done, right? That's the business arrangement they want. Now that doesn't mean that we don't have ethics and morals and professional conduct, and we EULAs and everything that talks about how we're going to deal with people's data and cybersecurity stuff. Like that's all there. But I've never once in my career been offered anything for anybody's data. So what's the value of it? Well, according to me, it's not worth anything because everyone tells me how valuable it is, but I don't have an offer for the farmer's data, so I can assure them of that. And the last thing I would say about that is in general, like people's data is housed in someone's digital warehouse, right? So I hold all this data, but I'm not building some fancy system to connect it all to the entire world, to every single platform that's out there with 1,000 APIs, and every country and province has their own ideas about how to connect data. Like this has been going on since 1998 when I began these conversations, and they've never ended. Nobody wants to pay for it. The infrastructure required keeps getting bigger and bigger and bigger and bigger. So I
Well,
don't see that this is problem's ever going to be solved personally. I think it's just maybe the basic forms of data and things we can discuss and make sure that the farmers can move their basic things around, and that's about it.
well, and I would argue that there's so much variability in that data that's being collected that a lot of it is garbage. Like honestly, a lot of it, of that data that's being collected on these sites, and Hanan is laughing in the background. I think he might agree with me. A lot of it just isn't that useful, even if you do try to aggregate it.
Well, and
Well,
I wanted to add that yes, data quality is one of the big issue, but in terms of data security, like through social networks and other type of digital communication, people entrusted abstract warehouse, digital warehouse, most sensitive data than farm production data. So it's not very different from, for example, medical records or other type of information that already within cyber infrastructure. So there are some concerns in terms of how to assure both data quality and data security. And recently there have been International Standard Organization Technical Committee 347 established to look at digital agri-food systems, which encompasses some of elements of digital data security. So hopefully within foreseen future, we will see some standards and protocols coming up with guidelines. So far, it's been self-controlled, like quite a lot of people working in this. They do have own protocol in terms of information security and information quality assurance.
so I'm sure we could keep chatting for a long time, but we're actually almost at the end here. Slav, I have one more question from you from somebody watching the webinar. If you can answer this quickly, we'd appreciate it. Are there any areas of precision farming that you think have the greatest likelihood of success, i.e. grower adoption, please?
Well, I kind of lean to there through my communication. So any technology that can avoid obvious mistakes, such as putting fertilizer or putting doubling our seeding, or putting plant protection material in area outside of cropping area or in area where plant is dead. So that definitely have strong potential. We have some research that in, for example, wild blueberry production with proper equipment, you can save 70% of plant protection chemicals. That's quite significant. And number of those type of examples is actually quite high. So every turnkey technology is something that relatively straightforward to get implemented. That would be number one to have it in place. But at the same time, agronomic services is there. So we are not looking at precision agriculture versus something very abstract. The status quo with uniform application rate based on traditional knowledge of agronomy is still one of case. So we are just selecting one versus another, and when the cost of information is getting lower, then going with more informed decisions is always going to give higher profitability. So it's a math.
Well, thank you, Slava, Hanan, Chuck, and Corey, for sharing your knowledge with us today. As you can see, we could just keep talking and talking and talking. There's lots to discuss. To our participants, you will receive a post-event survey. Our next webinar in September will look at food labeling. What does it mean when we read organic or grain-fed? How do those labels tell us about the production of our food? So please go to the simpsoncenter.ca website and subscribe to hear more about upcoming events and receive our monthly newsletter for information based on research about Canadian food production. Thank you very much for joining us today.